Hello everyone, this is Dr. MiteshGala. Welcome to Rough Book, a learning companion.
Hi, we are beginning with tangents and intersecting chords exercise B, the second part, and we'll try and cover some part of exercise C as well in this particular video. So what we already know, just banking on that one major property and trying to make you understand that once again. From the previous chapter, you remember inscribed angle theorem. If this angle is 60, this becomes 30. That is inscribed angle. From this chapter, we understood tangent secant property. If this angle arc is 60, then this angle becomes 30. So AXC is the common arc. The angles become equal directly. So if AXC is 60, ABC will be 30. Likewise, ACD also will be 30. So since these two angles are directly equal now, that is ABC, ACD, we call this as angles in alternate segments. Remember that angles in alternate segments is a major property in this exercise now that we are going to use. So please remember this. I call this as mountain and the valley. So mountain valley connection helps me to remember this particular property. Let's begin with sum number 13. They want you to prove this angle PAQ over here plus this angle ABQ at the bottom, PBQ. Total of these two is 180. That means they are supplementary is what they want you to prove. So to begin, you need to join AB. So you start by saying join AB. Now start picking up, pause the video, think how are you going to do this. If you do not get, come back, 100% I will help you. But first, try. So if you look carefully at this triangle PAQ, if I say this plus this plus this, the total is 180. Can I connect this angle here, QPA, to this angle over here? And why? So I'm just pulling it out for your reference. So this is angle PAQ and this is angle PBA. So I'm trying to say that this angle is equal to this angle. Can you tell me why? Angles in alternate segments, the trump, right? Likewise on this side, this angle is equal to this angle. A plus this plus B equals to 180. So A plus B plus this also 180. This plus this becomes the whole angle. So I have already given you the clue, rather the entire question. Try writing it on your own. If you do not get, come back and I will help you. Don't worry. So step 1, QPA equals to PBA. Likewise, step 2, PQA is equal to QBA. Reason for both of them, angles in alternate segments. Therefore, now the most important thing, jump into the triangle PAQ and see magic will happen. Angle QPA plus angle PAQ plus angle PQA. 180 angle sum property. QPA, I can write PBA. Likewise PAQ, I keep it as it is, PAQ, nothing can be written for that. And PQA, we can write QBA. Total 180. Reason will be from 1, 2 and 4. Now, PBA, QBA together will become PBQ plus PAQ equals 180. This is exactly what we wanted and that's it. Yeah, so it's just pure connection and the major trump property which I have been telling you all always, angles in alternate segments. Remember that and that will make your life very, very simple. Let's go with the next one. I want you to try sum number 15. So let's see if you can pick this up. Very good question and you'll have to really think, be with me, not lengthy but brilliant question. So pay attention now. Circles are congruent is what is given to you. Your target is to prove that CE is equal to BD. So CE is here and BD is here. How will you prove these two chords equal? So the property that we are going to use, I am giving you the clue. Congruent chords subtend congruent arcs. So prove the arcs equal and it will be sorted. but how to prove the arcs equal is a challenge. So be with me and I will make you understand. So we can say this angle is equal to this angle, vertically opposite. Yeah. So let's write angle EBC equals to angle DBM, vertically opposite angles. Now EBC can be written as half of arc CE. This angle is half of this arc. Reason, inscribed angle theorem. This is from the previous chapter. And angle DBM is equal to half of arc BD. This is tangent secant theorem from this chapter itself. Now these two angles are equal, therefore the two arcs are equal. Arcs are equal, chords are equal. Sorted. Okay, let's write. So these all, when you take together, you can say half of arc CE equals half of arc BD, and we will say from 1, 2 and 3, and therefore you can say arc CE equals to arc BD. Half gets cancelled, and since arcs are equal, therefore chord CE equals to chord BD. CE equals BD is what we wanted, and reason, you will write congruent arcs subtend congruent chords. Are we getting it now? So congruent arcs subtend congruent chords. Therefore CE is equal to BD. We managed to get it. I hope you are understanding and you are appreciating these sums. They're really brilliant. Yeah. Next, sum number 14. Come on, let's begin with this one. So we are trying to do maximum sums over here so that you get good advantage. So 15th I did. Now we are going to 14. Okay. Here this is given as 4. This is 5. This is 9. Your target is to get DE, and this is 90 degree given to you. So any property that comes to your mind? Great. Chords intersecting inside the circle. So AD into DE equals BD into DC. These two are known. These both are unknown. So let's find AD first. How? Pythagoras theorem. Get AD and then get DE. Once you get DE, that's your first part. Then we'll talk about the second part. So come on, first apply Pythagoras and then chords intersecting inside. All of you all should pause the video, try on your own and then come back. So step 1. We will say in triangle ADB, angle D is 90 degrees, and therefore AD square BD square is equal to AB square. Pythagoras theorem. So AD, we still do not know how much. BD is 4 and AB is 5. So therefore AD, so you know that the triplet is 3. So therefore AD is 3. Now that we've got this as 3, we will say chord or chords AE and BC intersect inside the circle, and since they intersect inside the circle, therefore AD into DE is equal to BD into CD. So what happens now? AD is 3, DE is unknown, BD is 4 and CD is 9. So therefore DE 4 into 9 by 3, so is equal to 12 centimeters. So we managed to get the value of DE. That's your first part. How many of you all got this correct? Write in the comment section and let me know about it. Great job if you're getting it on your own. Now they say AD is equal to BD is given. Prove that AE, the full thing, is equal to BC. So basically you'll have to prove these parts DE and CD equal to add and get the full chords equal, or maybe any other method that you can think about. So any clue that you have, come on, can you do it? I think I have got a clue. Okay, let me help you. This is isosceles. So I can say that the base angles are equal, correct? Now ABC, inscribed angle theorem says ABC is half of AC, and BAE, again inscribed angle theorem says BAE is half of BE. Using this, you're going to get AC arc equals to arc BE. Add AB to both sides, so we will get BAC equals ABE. BAC is full arc and ABE also full arc. So this arc, congruent chords CD and AE automatically will be equal. If you're still not getting it, hang on. Let me write the entire sum. Stay with me and 100% you will get it. Don't worry about it. Okay. So let me just start. First isosceles. So in triangle ADB, AD is equal to BD. Therefore, angle DAB is equal to DBA. Yeah, base angles. Let's write full names of these two angles. So step 11 on a fresh sheet. Angle DAB, I am writing it as EAB. And the other one DBA, I am writing it as CBA. Now the major thing, okay? So angle EAB is half of arc BE. Likewise, CBA, the other angle, will be half of AC. The reason for both, inscribed angle theorem. Now, since both the angles are equal, both arcs will be equal. That is, half arc BE is equal to half of arc AC. Half gets cancelled and therefore arc BE equals arc AC. What we do now is, we don't want BE, we want the full arc ABE. So we'll add AB on both sides. I'm sure till here you managed. Now just add arc AB on both sides. So arc BE plus arc AB is equal to arc AC plus arc AB. Reason will be adding arc AB on both sides. So when you add arc AB on both sides, what will happen then? So step 17, therefore BE plus AB, BE plus AB is ABE. So I will get over here arc ABE. Likewise AC plus AB, AC plus AB will give me this full BAC. So arc BAC. Now ABE is the arc, chord is AE. So I will write over here chord AE. Likewise BAC is the arc, chord is BC. So I will say chord BC. Reason, congruent arcs. Okay, this is not plus, this is equal to congruent chords. Sorry, arcs subtend congruent chords, and therefore our chords also are equal. And final step 19, that is AE equals BC. There you go. That's what your question was. AE equals BC. So what property are we majorly using is congruent arcs, congruent chords. Yeah, very important. These properties are from the previous chapter circle. So they're going to mix everything and they're going to make it challenging for us. I hope you're getting these sums. Yeah, brilliant. Let's go to the next one. The last sum from this exercise, I guess, sum number 16. And this is a board question 2010. So if you get this, 100% you will gain confidence. This is 65. This is a tangent at point B. So I've given you the clue. Center is O. Your target is BAO right over here. So think. Okay, this is the tangent. So this will be 90. Right? Now let's go reverse. If I want this angle, I'll have to focus on which triangle? BAO. For BAO, I know this. If I can get this one, then I will get this by angle sum property. How to get this? Very evident. Angle at the center. Double the angle on circumference. So I need this one. If I get this, I will get this. How will I get this one? So for this, which triangle are you going to focus? Super. BCD. Two angles are known. Easily you can get the third one. That will be 25. 25, this will be double. So 50, 50, 90, so this will be 40. Even without writing, we are able to answer. Isn't it great? So come on, write on your own all the steps, 2010 board question, and then we will meet once you finish. Pause right now and begin. So number one, we will have to say this is 90. So angle OBD is equal to 90. Reason tangent drawn at any point on the circle is perpendicular to the radius through that point. I hope you've learned all those statements, all the properties. They are in the description box. If you've not done it, right now download it, put on your softboard and learn it, please. Okay. So we get this 90. Alright. Now we're getting into this big triangle. So in triangle BCD, directly I will say DCB 180 minus 90 minus 65, that gives me 25. So we managed to get this one. So we said BOE double of BCE, angle at the center double the angle on circumference, so double it becomes 50. How many of you all could manage to write this remaining part without watching it? That's why I didn't record it purposely. So let's see. Once you get this 50, now get into this triangle BAO and then again apply angle sum property and you get this 40. Yeah, I hope you're enjoying this type of sums. Yeah, this is your second exercise which we already finished. Let's get into the last exercise of this chapter and do some parts out of it. Exercise 18C. Now in 18C, 1 to 4 are not important questions, you can ignore. 5 and 6, very simple. I'm giving it in homework. We'll directly get on to sum number 7. It's a semicircle that's shown. You must immediately complete it as a circle, okay, so that it becomes easily identifiable now for you. Your target is BDC right over here, this angle. To get this, which triangle are you going to get into? Yeah, BDC itself. If this is required, you need this, so that you can apply angle sum property. To get this, how? Opposite angles or cyclic quadrilateral are supplementary. You remember that? Yeah, so these two will be equal and you can easily find this angle. Once you get this angle, then angle sum property. So come on, pause the video and hit it on your own. Very simple sum, you should manage. So sum now, step number 1. Angle BCD plus angle BAD equals to 180. Opposite angles of a cyclic quadrilateral are supplementary. Complete statements, please write it in the exam. So now BCD is unknown plus BAD 70 equals to 180. So therefore I can say BCD is 110. Once you got this, now apply angle sum property. So in triangle BCD, I shall say angle BDC 180 minus 110 minus 30. And therefore my final answer BDC 140, so 40 is the balance. Yeah, how many managing it on their own? If you're doing it, guys, you will gain lot of confidence. Please keep it up. Next one, sum number 10. Put a star besides it. Very good question from exam point of view and slightly logical, so you'll have to be with me in order to understand this. EDF, so joining EDF, that's the angle over here, is equal to 90 minus half of A is what they want you to prove. They have given you that these are all bisectors, angle bisectors. So this is the angle bisector here all over. How are you going to do this now? So focus carefully. I don't want you to start this on your own. Please focus, it's slightly different, okay? So first thing I am saying, in triangle ABC, angle A plus B plus C equals 180. Full triangle, sum angle sum property. Since you want only A, I am keeping A as it is. 180 minus B, or we can say, let's keep it this way. Angle B plus C 180 minus A, because you have 90 minus something, so something related to that is what we have already prepared. So we will substitute this at some point of time. How and when, I will tell you. Now focus carefully, okay? Angle ADF. See, full angle is EDF. I'm breaking it in two parts. So first I'm taking ADF. So angle ADF. Can you tell me it is equal to which angle? Wow. ADF ACF. Can you see this and this angle? I'm drawing it outside for your reference. ACF ADF. Angles inscribed in the same arc. So ACF, angles inscribed in same arc are congruent. Further, taking the other half, EDF, come on, same way, EDF is equal to ABE. Same reason, both are angles inscribed. Adding these two so that I get ADF plus EDF, at least LHS will be sorted. And on this side, ACF plus ABE. Now focus, complete focus. ADF, EDF together will become EDF. Yeah. On this side, ACF. For that, can I say half angle C? See, ACF is half of angle C because it's the bisector. Likewise, ABE, can I say half angle B? Pull half common. So I will get EDF half of B plus C. B plus C is 180 minus A. That's why I told you to write this earlier. See? So now what's happening? Come on, pause the video. Now you can pick it up on your own. B plus C. I will write it as 180 minus A. Reason will be from 3 and 8. And my last step number 10. Therefore, angle EDF. 180 ka half is 90. I'm opening the brackets, okay? So 180 ka half 90 and half multiplying with A, so half angle A. That's exactly what we wanted. Yeah, isn't it a lovely question? Slightly different. That's why I told you to pick it up nicely and pay attention. Yeah, let's go to the next one. Sum number 11. This is simple. You will 100% be able to pick this up. They have told you that OD equals to BC. Very important step, and this is 20. Your target is to get this angle. Very clearly evident this is an exterior angle. So exterior angle is equal to sum of remote interior angles. So this plus this. Target is how to get this one now. If you get this, you are sorted. Now to get this, we will join OB. Now OD equals to OB, radii of same circle. I've given you the clue. Can you pick now? OD equals to OB, radii of same circle. OB equals to BC because OD equals to BC. So isosceles, base angles equal. So therefore this angle will be 20 plus 20, that is 40. And if this is 40, this also will be 40 isosceles triangle. Are you getting it? Perfect. So let's pick it up now and move ahead from here. So we'll get into this triangle first. Before that, we will say step 1, OD is equal to BC. Reason given. Step 2, OD equals OB. So OD equals OB and OD is equal to BC. Here I will say radii of same circle. Yeah. And step 3, therefore connecting these two, OD gets cancelled. BC equals OB. And therefore this is isosceles now. So now we can say therefore angle BOC, BCO 20. Yeah. So both of them have become 20. Now let's get this angle exterior one. So ABO equals to BOC plus BCO. Remote interior angle theorem. Don't write it as exterior angle theorem, that's wrong. So therefore ABO is 20 plus 20, which becomes 40. This is 40. Let's get this also 40. So in triangle OAB, we shall say OA equals OB, and therefore angle OAB OBA equals to 40. Finally, the exterior angle AOD equals to OAC plus OCA. Again, remote interior angle theorem. So therefore, AOD we don't know, we are trying to find 40 plus 20. So my final answer AOD equals 60 degrees. Got it? This was purely based on remote interior angle theorem. Yeah. Let's go with the next question. Sum number 14. Damn simple. Just focus carefully. 100% you will get. They say prove that this line bisects AB at point P. So just look at one circle and these two lines. Which property comes into your mind? 3 steps and the sum is done. You want to see? AP square, come on, I have given you the hint, is equal to PM into PN. Can you tell me why? Tangent secant property, not theorem. Likewise, on the other side, BP square, PM into PN. So tangent secant property. Now AP square BP square, see both these parts are equal, so therefore AP square is equal to BP square from 1 and 2, and the moment you take square root, AP is equal to BP. Write the final step as per the textbook that they have asked for. So therefore you can say line from MN bisects AB at point P. Yeah, so line from AB bisects line from MN bisects AB at point P. Getting it? Simple. I told you 3 steps. Yeah, 2 more steps. I'm sorry, but yeah, those were all related only. Let's get into the last question, 15, and then we will pause with this video. I want everyone to try this on your own, no matter to whatever extent you can. At least get one part. So DBC, damn simple. 40. Why? Angles in alternate segments, mountain and the valley, so both are equal. Yeah. Next, BCP. So you can say this is the diameter, so this is 90, 40, so this will be 50. Correct? Linear pair. And then ADB. So this is 90, again angle in a semicircle, this is 60, so this will be 30. Simple? Come on, write the entire sum on your own, pause it right now. So step 1, I will say angle DCQ is equal to DBC, angles in alternate segments, and therefore, so DCQ equals to this, so therefore angle DBC is going to be 40 degrees. That's our first angle that was asked. Now let's get into the next one, BCP right over here. For this we'll have to say this is 90, say this also 90, so that you have to write these in only once. We'll save our steps. So BCD equals to DAB equals to 90. Reason angle formed in a semicircle is a right angle. Please write the complete statement. Finally, DCQ plus BCD plus BCP equals to 180 linear pair. So therefore DCQ is 40 plus BCD is 90 plus BCP we are trying to find equals 180, and therefore I can say BCP is equal to 130, so 50. So we managed to get our second part that was asked. Now for the last part, let's jump into the triangle BAD. Therefore angle ADB is equal to 180 minus 90 minus 60, because this 90 is already proved over here, so you don't have to write it all over again. And step 9, therefore ADB equals to 30 degrees. So we managed to get our last one as well. Wow. I hope you are enjoying this chapter and the video as well. Please write in the comment section and I will shout out your name in the next video. Homework 18C, sum number 5, 6, 10 and 15 I have asked you to repeat because they are good ones. You will gain some confidence for sure. Until the next video, take care, stay safe, pray for everyone and please be honest. Bye.
Hope you had a lovely mathematics experience with the rough book, our learning companion.